And here we are, another normal day at activereach Limited, and I just thought I'd talk to you a bit more about DSL Statistics. I thought it would be useful to take a look at how to get this information from your connected device. So we're going to have a look at some Cisco routers, and we're going to compare the various DSL statistics. Here's a device here, and if we log into it and we do a show controllers VDSL 0, which is the command you'd use in a Cisco router to get the information you need, the output is thus. And we are going to look past this initial piece of jargon. Now you can see here the trained mode. You can see this one here is trained at ADSL 2+, and if we look further down on the output, we can see that it has an attenuation of 37.5 dB and a noise margin of 5.6 dB. And the attainable rate is what the router believes that it can achieve, and the actual speed is lower down here where it says speed under DS channel 0, and we have achieved a speed of 9019 kbps. About 9 megabits per second. So that's pretty good. 37.5, which is relatively high, so quite a long line, not completely out of limits or anything like that, but for 37.5 dB you'd expect with DSL 2+, 9 megabits a second, pretty standard really. And a noise margin of 5.6 is quite a low margin, but that means that it's achieving that slightly higher speed and the line is perfectly stable, so there's no local interference, no environment variables there which are causing any interference on the line, so it's not dropping, so that's perfectly acceptable also. Let's take a look at another one. This is another router on a different DSL circuit. As you can see, this is also ADSL 2+. If we have a look at the attenuation of this one, it's 30 dB with a noise margin of 5.6. And if we just scroll down on the output, or press space to see the rest of the output, we see this is achieving 13 megabits per second, which is a higher speed, and that is due to the fact that the attenuation is that little bit lower, so it's getting that bit of extra speed, and you can see the attainable rate is also faster. Let's have a look at a third one. This is another Cisco device, and we're going to do show controllers VDSL 0. We're going to scroll down to find the interesting bits. Here we go. Attenuation on this one much lower, which is a good sign. Low attenuation is faster speed, it's a shorter line. 23.5 dB attenuation, and the noise margin is 9.1 dB, so higher noise margin, but that doesn't indicate any problem. The speed we're achieving here is 18479 kbps, which is 18 megabits per second. And again, you can see how the speeds on these three examples have all stepped up in speed, while the attenuation has gone down, the speed has gone up. Another interesting thing to look at is how the noise margin fluctuates, and if we append a pipe include and then a keyword onto our Cisco command, in this case we're going to do show controllers VDSL 0 and then pipe include noise. This is a nice way to just have a look at the noise margin and nothing else. So as you can see, it outputs the noise margin for the downstream and the upstream, and this one's got a 5.5 dB noise margin, but as we continue entering that command we can see how the noise margin might fluctuate, and in this case you can see it moves from 5.5 to 5.6, and then back to 5.5 again, and on the upstream it goes from 8.2 to 8 to 7.9. So we can see that there's this bit of fluctuation on the noise margin, but that's perfectly normal. This is a copper pair, it's very susceptible to interference from electrical devices and other things that can interfere with the frequency, and to see a fluctuation of 0.1 dB is perfectly fine. The problems begin when you're seeing huge fluctuations of 1, 2, 3, 4 dB, and that can cause the line to drop. While we're at it, we'll have a look at some different routers. A Vigor 2820 output here, connected to a DSL 2+ line, and here you can see an attenuation of 22, which is a good low number, and the SNR margin is 20, which is a high number. So the speed here, though the SNR is low, it's only getting 9.7 megabits a second. The reason for that is the SNR margin is higher, or the target is set to be higher, which means this line is set for more stability as opposed to more speed. Let's have a look at another output. Here's for a Netgear, and this Netgear is a very high attenuation of 62.4 dB, and really that's a very long line, and it's beyond the limits for DSL. So this router is lucky to be connected at all, really. And you can see the speed is very, very low, 1432 kbps, and the noise margin of 7.1, which is fine, providing there's not too much interference. But I think this connection is hit or miss, really. But it's working, it's up, they're getting some speed. They're probably a rural location somewhere. And let's have a look at another Netgear device here. Again, slightly long line here, 52 dB, and a connection speed of 6221 kbps. Long line, pretty good speed. And again, if you look at the noise margin, 3 dB, very, very low noise margin. And it's possible that this line is experiencing some drops. That's a very low noise margin, fluctuation of 3 dB, and that will drop. Let's have a look at another Draytech. Here we go. Loop attenuation 17, very low. Downspeed only 8128. Noise margin 12. Why is this achieving such a low speed for such a low attenuation? Well, quite simply because this is set to DSL 1. That's G.DNT mode, which is DSL 1. Don't get many of these about anymore, most tend to be DSL 2+, but this is obviously DSL 1, and 8128 is the highest speed possible on a DSL 1 line. Thanks for watching. See you again soon.